Hi, welcome to AIMS University, Malaysia. This is Dr. Sridevi back again to introduce you a new topic for today's session. Positional isomerism. Today's session, I am going to reveal you what is the definition, examples, properties, and applications of positional isomerism. Let's see what is the definition of positional isomers. Positional isomers have the same molecular formula but differ in the position of a functional group on the carbon chain. Now let's see the properties of positional isomers. They are the example for structural isomerism. Molecules have the same carbon skeleton, they are with the same functional group, but the functional group is in a different position. Molecules have similar chemical properties but with slightly different physical properties. Have a look on this example. Here you are given with two examples. Example on the left hand side is with a functional group attached to the first position. Example on the right hand side has a functional group attached to the second position. Though their positions are different, both comes under the example of positional isomerism. When we look into the example of positional isomerism in alkenes, we have the best example, pentene. A minimum 5 carbon atom is expected to show positional isomerism in alkene. A carbon chain of 4 carbons is not an example for positional isomerism in alkenes. In the first example, which is on the left hand side, it is pent1ene, showing that the double bond is in between first and second carbon atoms. The other example, which is on the right hand side, if you shift the double bond from 1 and 2 positions to 2 and 3 positions, you get another isomer. These two are the best examples for positional isomerism in alkenes. Now look at the example of haloalkanes showing positional isomerism. There are 3 examples given here: 1 chlorobutane, 2 chlorobutane and 3 chlorobutane depending on the position of the carbon atom. 1 chlorobutane has a halogen attached to the first carbon atom. 2 chlorobutane has a halogen atom attached to the second carbon atom. But we cannot call the third structure as 3 chlorobutane. It is 2 chlorobutane. Because there are no other functional groups attached, we have to count the carbon from the least preferable position to the functional group. Moving the chlorine along the carbon chain makes new isomers. The position is measured from the end nearest to the functional group. The third example is not a 3 chlorobutane, it is a 2 chlorobutane. There are 2 more structural examples or 2 more structural isomers of C4H9Cl, but they have the longest carbon chain of 3 carbon atoms. There is one more example here for you. It is bromobutane. Bromobutane can exist in 2 positional isomers. One is 1 bromobutane, which is on the left hand side, and 2 bromobutane on the right hand side. Coming to the positional isomerism in cyclic aromatic compounds, that is benzene ring, we have a relative position of positional isomerism. There are 3 examples given here, that is 1,2-dichlorobenzene, 1,3-dichlorobenzene and 1,4-dichlorobenzene, showing the positions of halogen groups attached to the different positions on benzene rings. In the first example showing 1,2-dichlorobenzene, it is also called as orthodichlorobenzene. It has 2 halogen groups attached to the first and second carbon atoms. In the second example, the halogen groups are attached to the first and third positions. In the third example, the carbon atoms are with first and fourth position attached with the halogen atom. So the second, third are meta-dichlorobenzene and para-dichlorobenzene. So there are totally 3 positional isomers for dichlorobenzene, that is ortho, meta and para-dichlorobenzenes. Now look into the pharmacological applications of positional isomerism. Here we are given with 2 structures. The left one is N-tertiary butyl non-epinephrine and the right one is tarbutylene. Tarbutylene has longer duration of action as the position of OH is at 1 and 3 but not 1 and 2. Catechol in N-tertiary butyl norepinephrine is replaced by resorcinol in tarbutylene. So these are the best examples you can show for positional isomers. Now look into the second application of positional isomerism. Here you are given with 2 examples, pentobarbital and amobarbital. Pentobarbital and amobarbital both belong to barbital family. They are the best example for positional isomers. Both differ only in the makeup of 5 carbon side chain attached to the barbiturate ring system. Pentobarbital has shorter duration of action compared to amobarbital. Amobarbital has intermediate duration of action. They are the best examples for positional isomerism. Thank you for patiently listening about positional isomerism.